of parallel lines. So a bunch of these, again, are going to give us a picture. We're either going to be answering, like we're answering some type of question about them. There's only like 1 or 2 proofs that we're doing with this section. So the first one say to state the postulate or theorem that allows you to conclude that J is parallel to K. So in number 8, we're given that J is parallel to N and K is parallel to N. And our lines look something like this. J, K, N. So that's all given information there. And so they want us to use one of our theorems or postulates to explain why these are, why J is parallel to K. So in this section, we have 2 theorems, but the first one, theorem 3.11, says if 2 lines are parallel to the same line, then they are parallel to each other. And it gives us 3 lines in the picture on page 157 that looks a lot like this. If you draw the pictures in your theorem postulate book, you'll see that it looks just like this. And so the theorem that would make this one true, or that would allow us to say that J is parallel to K, is theorem 3.11. And that's all you're doing on those ones. So I'll remind you again, if a theorem has a name, we're going to use a name, but these ones just have a number, so we're just going to use the number for those. 10. We're given that angle 1 is congruent to angle 2, and we've got lines and we have the angles there that we're given. So we're told that angle 1 and angle 2 are congruent to each other as the given, and we're trying to prove that J is parallel to K. What would make that true? Yep, the alternate interior angles converse. So remember, the converses are what is proving to us that lines are parallel, in case you're mixing them up. Explain how you would show that K is parallel to J. State any theorems or postulates that you would use. The explain part is sufficient if you just state the theorem or postulate that you would use to do it. So I don't really know why they have this in like a little separate section from the previous problems, but nonetheless, here we go. Number 12, we have 2 lines going this way, and a transversal cutting through it like this. This is N, this is K, this is J, and this is marked as 99 degrees, and this is marked as 99 degrees. And I'm trying to show that K is parallel to J. So based on my given information, what theorem or postulate would give that? If I'm proving they're parallel, which one is it? Alternate exterior angles what? Converse. Yep. Anytime we're trying to prove that something's parallel, it's going to be the converse for it. Obviously, I know you don't all have them in front of you right now. That's what your theorem and postulate book is for. Right now, I'm just asking you to wing it, essentially. All right, 16. Still explaining how you would show that K is parallel to J. These may involve a little bit more work. We're not proving anything. We're just going to be showing it and explaining it out. So we may have to do a little bit of math on some of these. So 16, I have 2 lines going up and down. And a line cutting through it this way. And then over here, I have an angle. This is marked as a right angle. This angle is 35, and this one is 55. This is K, J, and N, and we're trying to show that K is parallel to J. And as if with many of these problems, there can potentially be multiple answers that work. This one really only has one that I can really definitively think of right now, but some of these may have sample answers if you're checking your work where they have different options. Do you have a question?
No.
Oh. Huh?
I'm sorry, we can do it about really quick.
Quickly. Okay. So, how would I go about showing that K is parallel to J with the information that I know?
Add 55 and 35.
Add 55 and 35. And what does that help me with?
It's 90 degrees.
Okay, so this angle then here would be 90, so I can add that on. And what is that going to tell me?
Both of these are right angles.
Okay, both are right angles, so what does that mean about the lines? There's something I've got to say before I can do that. What has to be true about this line and this line if this is a right angle?
Perpendicular.
So I would first need to say, so J is perpendicular to N, or N is perpendicular to J, doesn't matter. So then K is parallel to J by what?
Corresponding angles.
Exterior.
Theorem 3.12. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So we know that both of these, K is also perpendicular to N, and N is perpendicular to J, so that means that those lines have to be parallel. So by theorem 3.12. All right, 18. Explain how you would show that G is parallel to H. So again, we have a picture. As a reminder, you should be drawing the pictures when you do your homework. So this one's going to be a little bit more involved than the previous ones. We're essentially doing the same kind of thing. It's just X is in here now instead. So I'm trying to show that G is parallel to H. So something that I do know at a minimum. Oh wait, I guess I should label these lines so we can see what's what. This is G and this is H. The transversal doesn't have a name on this one. Okay, so I'm trying to show that G is parallel to H. So this one, I can see that G and the transversal forms a linear pair, right? Because I have one angle here and one angle here. So G and the transversal, if it had a name, obviously, I would just call it that, forms a linear pair. What do we know about these angles of this linear pair?
Alternate interior angle.
They're 90 degrees.
Why?
Because of here on 3.12.
Huh?
Here on 3.12. Is there something there?
Well, I'm getting to that. They're supplementary, right? A linear pair is supplementary, and these are both x, so that means they have to be what? What's the word? Starts with a C. Congruent. So the G in the transversal forms a linear pair of two congruent angles. Therefore, the triangle that is in 3 dots means therefore both are 90 degrees, which we already had said. So G is perpendicular to the transversal. And then, because that's true, theorem 3.12 says that G is parallel to H. So obviously that one had a little bit more to it. But we have to express those things in order to get to the final result. You got 39, right? Panicking for a second, thinking it was 25, and I was like, okay. 22. Determine which lines, if any, must be parallel and explain your reasoning. So we're given a picture and we have to tell if the lines are parallel or not. So we have 2 lines going this way and 2 going up and down. This is H, J, K, and G. And then they have angles marked for us. So remember, single, like just single is telling us that those are congruent to each other. So like this one is congruent to this one. And if it's like a double, that means that these two are congruent to each other. If we had other angles that were congruent to each other, then we could like keep going with 3 or something like that. But usually you're not going to have that many sets that they're giving you. All right, so given what we have here, I know that both of these are congruent, and I know that both of these are congruent. With that information, our basically only have 2 options. Are H and J parallel, or are K and G parallel, or like are none of them parallel to each other? Okay, why? What allows us to say that?
Because they're both the same angle on line G, which means they're congruent.
They're both the same angle on line G. What do you mean?
Both angles are congruent against line G.
Oh, you're talking about these two. I was looking at those two for some reason. Yes, and what is the reason then for that? Or like what's our official name for it?
Theorem 3.12.
Nope. That would have to be perpendicular information. Something from last section.
Corresponding angles converse.
Yep. Corresponding angles converse. Okay, so we see this. This one and this one are corresponding angles. So that means that those lines have to be parallel to each other, with this being the transversal cutting through it. All right. Tell whether the statement is sometimes, always, or never true. 34. In a plane, 2 lines that are perpendicular to the same line are parallel to each other. Is this always true, sometimes true, or never true?
Always true.
Yep. Why?
Geometry 112.
Yep. So we don't have to put that, I'm just talking through it. "36. Through a point not on a line, you can construct a parallel line." This is always true, sometimes true, or never true.
Sometimes.
So if you have a line and you have a point not on the line, can you construct a line through that point that's parallel to the other line?
Yes.
Yes, so this is always true. That's kind of a throwback to, I don't even know, chapter 1, chapter 2, something like that. All right, 38 is a proof. They've actually given us the statements of the proof. The answer that they use is like a flowchart proof, but I'm not going to do that. We're going to do it with statements and reasons instead. But 38, we're given that M is perpendicular to P and N is perpendicular to P, and we're trying to prove that M is parallel to N. And we have this picture. You can just sit right there. Thanks. This is M, this is N, this is P. They have these angles marked as right angles 1 and 2. So again, with this one, if you have one like this, they actually give you all of the statements. You just have to write the reasons and put them in order. But I'm just going to, obviously if you have your book open, you can see them. But we're going to pretend that we know nothing and we're going to work through it this way. All right, so what is our first step always to a proof? Given. Now, both of these things are perpendicular. If you want to write them as 1 or if you want to write them as 2, it's fine. When they do their answer out of their flow chart, they're writing them separate, but it really doesn't matter. So I usually just write them together. So M is perpendicular to P and N is perpendicular to P because those are given. All right, so the next thing, the wording of it would probably be a little bit different if they didn't give us like tags of like what we're using. But they basically are talking about how each of these angles are right angles. Okay, so statement 2, again, I could do this as 1 or as 2 separate things. Angle 1 is a right angle. And if I wanted to, I could just then put angle 2 as a right angle. Or I could have that as step 2 and step 3 there. It doesn't matter. And that's because perpendicular lines form right angles. And that symbol is basically telling us that those are perpendicular lines. So what else must be true if we know that these are both right angles?
They're congruent to each other.
Yep. Angle 1 is congruent to angle 2. It's because right angles are congruent. So if that's the case, what can I ultimately say and why?
M is parallel to N.
And And what's the reason that I can say that?
Three point twelve.
Yeah, that's fine. The other one that I thought of, the reason I went back to look, is these are also corresponding angles. So corresponding angles converse would also work here. So either of those would be fine, and an acceptable answer for that.
I thought it was impossible.
What?
The corresponding. Is that a converse or is it
The corresponding angles converse would prove that they're parallel. But yes, technically the thing about corresponding angles is the postulate. But the converse is just the converse of that. We don't call them like a postulate or a theorem. All right. Any questions on that? All right. Problems.
We did it 46 or 46?
39.
Oh. I was so close.
9 through 21 odd. And then $35 and 37.
That's not a lot. I use the restroom.